Lastly, let's find a value of our load resistance that maximizes our power transferred from the circuit on the left of terminals A and B. And we want to determine the numeric value of our maximum power transferred. Now, if you recall from Lecture 17, Example 4, we solved this particular circuit by determining our open circuit voltage and short circuit current. In doing such, we calculated our Thevenin resistance to be 12 ohms, and our open circuit voltage to be 12 volts, as well as our short circuit current to be 1 amp. Thus, to maximize our power transfer, we should set the value of our load resistance equal to our Thevenin resistance. That is, our load resistance will take a value of 12 ohms. Thus, our maximum power delivered to our load resistor can be expressed in terms of our open circuit voltage and our load resistance, such that our maximum power transferred is 12 volts squared per 48 ohms, or 3 watts. Similarly, we can calculate our maximum power transferred via our short circuit current squared times our Thevenin resistance per 4, which would be 12 ohms times 1 amp squared per 4, or 3 watts.